So here is what you'll see on the final itself. 2 written questions. This is what we're doing there. This is also when the final packet is due. This is when we'll be checking the final exam packet itself for points. We're checking that for points regardless of whether or not you are taking the final. So 2 written questions. It'll be 2 questions, and I'm going to tell you exactly what those 2 questions are, so you're going to be ready for them. I'm not going to tell you the exact numbers, but I'm going to show you exactly what the questions are going to look like. Question 1 will be a proof. I will want you to show, these are basically things that I don't want to leave to multiple choice. I want to see these shown out. So 1 is a proof. 2-column proof and sentences. So I've shown both ways. So you should see, I want to see that you can do it both ways and write it out both ways. We'll go through a practice question here with that in just a minute, and I'll tell you strategies and all that kind of stuff. That'll be question 1. Question 2 is going to be a coordinate proof with slope formula, midpoint formula, or distance formula. It's going to be proving that something is a parallelogram. You can use whichever formula as long as you explain it. And again, we'll talk about that in a little bit. Then, on the final exam day itself, 50 multiple choice questions. Okay, 50 multiple choice questions. And we're going to do this for your benefit. We're going to do this for your benefit. For the questions, study your final exam packet. All right, there is no big curveball question that we haven't gone through in the notes, put on a test, put on the final exam packet, and done. Okay, I'm not out to throw something completely unexpected at you. If you know how to do all the problems on the final exam packet, then you're going to know how to do the problems on the final, because the exam packet is to show you here are the types of questions that you should know how to do. Okay. Here's what we are doing for your benefit. For your benefit, you will do better on the test this way. The first 40 minutes, you're going to be handed a paper with all the questions. All 50 questions written out on paper, and you're going to have it just on paper. So you'll enter Canvas multiple choice, but for the first 40 minutes, the Canvas multiple choice will be closed to you, and you will just work on it on paper. The reason for that is that if you work it out on paper, you're going to get more of them right, and you're going to do better. It's just proven from past exams I've seen people do. If you actually take the time, work on it, have to write it out and work it out, you're going to do better. So we're going to make you do that for the first 40 minutes. And then on the last 40 minutes, we will open up the test on Canvas. It's going to have all the same questions, and you can just go through and enter all your answers. And that should give enough time, like if you have technology problems, it's not 10 minutes, where you're going to have to be on the sprint to hastily enter all the choices. You're going to have plenty of time. If you run into technology problems, we can work those out. If you have a question and you're looking at your answer and, hey, that's not one of the choices, then you're going to have time to re-look through the problem and redo it. I haven't had a major issue with people finishing my final. So don't worry about that. But this will make sure that you're working on it on paper and working through it step by step. So again, we have 2 ways that we have of writing these proofs. One is in full sentences, one is with a 2-column. And I'm going to be asking for you to show both. That's the idea here. So take 2 or 3 minutes here and just take a look at it first, and then we'll go through it together. But I'm going to give you 2 or 3 minutes to take a look at it and see how far you can get on it in those 2 or 3 minutes. All right, now I'm going to go through this fairly quickly, because we went through a bunch of examples earlier this week. So we're going to start with our first given, which is that A to B and C to D are what? congruent. And our reason? It's given. Guess what? That tells us a pair of sides is congruent, so we don't need to do anything else with it. So we turn to our next piece of given, which is not that A, B, and C, D are congruent, but instead that they are parallel. All right. Now that does not tell us a pair of sides or a pair of angles. So now that tells us we're going to do something else with it in step 3. All right, so here's AB and here's CD, and we're going to go ahead and mark them parallel. Let's mark them congruent as well. And now we have the transversal cutting through it. So that tells us now we know what angles we're going to mark, which are angle BAC congruent to angle DCA. And that's because those are what kind of angles? They're alternate interior angles. Alternate interior angles. All right, now we go to the next piece of given information, but there isn't one. So now we turn to the diagram, and we look at the diagram and we see, what is it? It's reflexive property. So for step 4, we're going to do reflexive property. So that tells us our reason. So what are we going to put for our statement? Where was that reflexive property? A to C, congruent to, well, itself. And why? Reflexive property. It's a common side in the triangles. So that's a pair of sides. These alternate interior angles are a pair of angles. So now we can say that our triangles are congruent. So I'm going to go A, B, C. And be careful here because this is a rotation. So that means that A rotates around to C. So because I wrote A first, I'm going to write C first in the other triangle, and then B rotates down to D, and C rotates around to A. C, D, A, in that order. And what was my method? It's side angle side. I've got an angle included between the two sides. All right. Now we're almost done. We got 2 more steps. Now I'm going to start with step 7 because step 7 is what we're being asked to prove, which is that we want to prove that B to C is parallel to A to D. Right? That's the end goal here. So if we want to prove B to C and A to D, then what we're going to do that is to once again use a transversal here and talk about these 2 angles. Well, good news. We know that those 2 angles have to be the same. BCA and DAC. Those 2 angles have to be the same. And why? Because we just said the triangles were congruent. That means all the matching sides and all the matching angles have to match up. And that is CPCTC, which is, of course, step 6. There's 7. Now, how is that going to lead to them being parallel? Well, those angles are, guess what? It's alternate interior angles again. And I'll go ahead and say that it's the converse. And again, the difference between the statement and the converse, this is a little thing, but between the statement and the converse, the statement says they're parallel, so the angles, The converse switches and says the angles, therefore parallel. All right, now I said we want to write these as sentences. So a couple things to keep in mind before I show the sentences to you. One, the font's bigger so you can see, so it looks longer than it is. Two, you do not necessarily have to have this entire thing written out exactly word for word. What I typically do for grading this is what I'm looking for you to demonstrate is your knowledge of the vocab. Understanding what the symbols mean, what the acronyms stand for, what the different vocab terms are, how you know to look for certain things. So, for example, I'm going to go ahead and mark off. There's 5 points possible. I'm going to go ahead and mark off every time I say something that has demonstrated my knowledge of the vocab and of these terms that I'm talking about. So I began with the given information, which is that segments A, B, and C, D are congruent. Okay, so I'm showing I know that that symbol means congruent. And I'm showing that I know that that symbol means parallel. There's one. Since they're parallel, it creates a transversal. Oh, that's a good vocab word right there that I'm showing that I know. That cuts through the parallel lines. That means the alternate interior angles. So that shows I know the alternate interior angles are supposed to be congruent. Common side. Okay, so I'm not just knowing to put reflexive property sometimes. I know why I'm using reflexive property here because we have a common side. I'm showing I know what side angle SAS stands for, side angle side. I'm showing that I know that I'm using that because the angle is included between the sides. I'm showing that I know what CPCTC stands for. I'm showing that alternate interior angles are supposed to be congruent, and I'm showing that I know that that's when to use the converse. You'll notice that's quite a bit more than 5. So you don't necessarily need to have every single detail that I have laid out here, but this gives you an idea of what formulas you're looking for. Okay? I'll come back to this in a moment, but I want to show the last thing here, which is question 2. Question 2 is a coordinate proof. The good news is it's going to be a parallelogram. So that means we had all 3 formulas in play. So that means whichever formula you're most comfortable with using, slope formula, midpoint formula, distance formula, use it. You got one that you know like the back of your hand, you know that distance formula really well, then use the distance formula. The thing that you need to know is why the distance formula tells me parallelogram. So let's go through those very quickly. For slope, if I see those slopes matching, again, this is part of what I'm looking for. Not just that you can do the slopes, that's going to be a majority of the points, but what do the slopes tell me? Same slopes tell me that those are parallel. That those are parallel because they have the same slope. And then you would do the same thing for these other slopes. Again, these are right from your notes. So you can go back through these notes and study through them. Or if you're using the distance formula is the one that tells me if they're the same distance, that means they are congruent. Okay? So it's about knowing what those tell you. If it's midpoint, we did it for the diagonals. Oops, this is midpoint. Midpoint, we did it for the diagonals and showed that the diagonals are bisecting. Midpoint tells me about bisecting. So it's about knowing which formula tells me what. And you can use whichever of the 3 formulas you're most comfortable with using, as long as you know what it tells you. Okay?